Okay, hello everyone. I think, and I hope you are enjoying the Erasmus Plus course, and that you are learning a lot about recycling plastics. Then I think it is very, very important issue. We have prepared. Okay, I want to introduce you also my colleague Elena Canellas, who is connected as well. Elena? Okay, can you?
Hello, everyone.
Okay. And we have prepared a presentation on PPT, but before going to the presentation and to explain a little bit more, I would like to hear you about your impression of the course, especially about this module, and also answer the questions if you have some doubts, some questions, okay, to ask. Okay, you can switch on your microphone. In case you have some question. Do you want something to say?
So maybe I will try to start. I think this module is very well organized, and what is very nice, all the materials are prepared in a very clear way, and is very easy to be followed by. And I think that what is good in that module is that there is not too much material to be studied, and we have, I think, most of us could have enough time to do that. Because in comparison to previous two modules, some of people had the impression that there is not enough time just to do everything what was given in the material course. So this is the first module we could study with pleasure. So thank you very much.
Yeah, thank you.
Okay, thank you.
I totally agree with Eva. So the workload is reasonable and still very informative. Maybe what I still long is that maybe if possible, it would be nice to see some videos of the recycling. I mean, this process itself, some practical kind of example. Like we had in module 2 about those technical issues that were shown by the video. So maybe that is one thing that I long, but I totally agree that it has been very informative and interesting.
Okay, thank you.
Thank you.
Have you seen the video from Coca-Cola?
I have not gone through all the material yet, so at least I have not seen that particular video yet.
Yeah, but in the presentation we have prepared today, there are two other videos, more informative, to illustrate what the mechanical recycling means. Okay. And
thank you.
How it is performed, and you will see different plants, but different size. But I think the best one is definitely the video you have in the module uploaded in the course, which was prepared some years ago by Coca-Cola, and okay, and I think it is it is a very good one that explains better what the mechanical recycling means, especially for those plastics, so in this case is PET, dedicated finally for food contact. Okay, so I think it is a very good one, just to illustrate the system. Okay, there are more comments. Something you want to ask or you want to comment before going to the presentation? Somebody else wants to comment? No? Okay, then I will share the screen with the presentation we have prepared. Can you see here? Can you see it?
Yes, that's visible. I just have a question because we received a link to the recordings of the previous session. Will we also receive the link to this one?
Yes. I will. Yes. This everything will be recorded, and then you will have the recorded session in the Moodle. Okay.
Yeah. Thank you.
Later. Then confirm that in presentation mode you can see it.
Yes, we can.
And if I pass, you can see.
Yes, everything works.
Different. Okay, different. So we will explain a little bit an additional information that it is. We think it is important. This is just a presentation of the Erasmus and the participants and so on. This is just a presentation of the module, really, the residue management and standardization. You know that there are 3 different sections: the logistics and sorting, the recycling systems and novel business model for the second life of residues, and also the third part is the economic, environmental and legislative aspects of plastic recycling. Okay, so there are several there are several ways viable to reduce negative impacts of continuously growing plastic pollution. So it's a better product design. It is very, very important to be able to use the alternative materials. You know that the plastic strategy published by European Commission forces us to recycle, to use the biomaterials, biodegradable plastics, to eliminate the single use, and so on. So we have to do a great effort in getting the better planet, the better world for using the plastics and the alternative materials. Also, we have been forced to use higher recycling rate and increasing the waste collection and recycling rates, improving sorting and decontamination abilities, as well as boosting market for recycled plastics, and also to improve the cleanup and remediation activities, such as the cleaning up plastics in the beaches and collecting plastics from rivers and oceans. Okay, so you have here the scheme of a circular, the scheme of a circular economy according to the EU Parliament. And this is, it's not very, very recent, but because this is 2015, but you see that they promote the recycling and, but not only the recycling. You have seen and you have followed the previous modules about the design, about the production, manufacturing, and so on. So, collection and recycling, we will see in this model. Concerning the recycling, we have to distinguish, as you have seen in the model, the mechanical recycling and also the chemical recycling. But the most advanced by far nowadays is the mechanical recycling. Perhaps 20 years ago, the industry started to recycle, to reuse and recycle plastic bottles. And the plastic bottles, mainly from PET, this is a curious fact that all industry agree to use the same material. This doesn't happen in other applications. For example, in flexible plastics, there are a wide series of combinations of different materials to make the flexible materials. But this doesn't happen in bottles. The industry agree each other to use only the PET for bottles, mainly for bottles and especially for food, but not only for food, cleaning the detergents and cleaning liquids and many other different applications. Consequently, there are a high volume of PET bottles, and this made economically viable to invest in recycling and to invest in, to collect, to sort, and to invest in the recycling technologies for being recycling the different bottles. Following the bottles were the trays, and the trays usually apply on food, for example, and to food in the supermarkets. Then most of them are nowadays from PET, and these PET trays, as well as the PET bottles, are mechanically recycled at the moment. So depending on the country, because in the different member states, the collection system varies. In some cases, are all plastic together in a container, but in other countries, they distinguish between the color of the bottles and the type of plastics, and only bottles, only trays, or whatever. So first collection, then sorting, then after being sorted, they have to wash, they have to grind, and from these flakes produced, this is the first input for the mechanical recycling of the PET. So you can see here the collection in different systems. The yellow container is what we are using in Spain, but you can see here in Germany, for example, and this is in a station, the final station, in which you put the bottle, and the bottle is pressed to reduce the volume, and in some cases, a reward is given to the consumer that adds the bottle in the machine. Here you can see depending on the input material and the sorting plants, various sorting schemes. The different to distinguish to separate by materials, the bottles, the trays, the metals, using a magnet, for example, and optical separation to separate the drink cartons and bricks. And also the eddy current to separate the aluminum, for example, and again the ballistic separator to separate the bigger pieces, and then 5 different optical separators to distinguish between the different polymers. That I have to say that the most of them are dedicated or the highest volume is definitely for PET. For PET, different colors, green, blue, and colorless. Okay. Then using these different fractions, each fraction is sent to the specific recycling plant. There are different recycling plants in the member states. Most of them are for PET, but there are also other plants for PP recycling or for HDPE, for example, at the moment. So the conventional recycling processes usually involve water-based washing. But this water washing is the main purpose is to clean up the surface contaminations, to eliminate the dust, to eliminate food residues, for example, labels, glue, and everything attached to the plastic. So this is directly applied to the recycled plastics before grinding. Then once the washed material goes on in the plant, they are grinded and washed again. Usually this water washing is using also some kind of detergent or some kind of chemical or acidic, or usually depending on the plastic, or alkaline alkaline salt, just to remove completely, as much as possible, all the contaminants. And after this washing, the recycle technology is applied. In a module and in the presentation you have, we have proposed different you to check the web page from EFSA, in which you have different opinions about the evaluation of the different technologies dedicated to recycle plastics for food contact as a food contact material. And then you will see that the many different technologies are applied nowadays. There are differences, of course, in the contamination efficiency between them, but it is very useful for you to check a little bit the different technologies. If you have some doubts, please don't hesitate to contact me and I will explain as much as possible. I will explain the different technologies. There are other kind of recycling systems which are called open loop. The open loop or closed loop, just the opposite. The open loop is when recycled plastics are used to produce other products. And they are coming from the different applications. They are recycled and then they will be produced. They will produce other applications, other bottles, trays, or straits, or whatever. The closed loop is just the opposite. The closed loop means that the same company put in the market the material, collect themselves the material after consumption, and then was consumer material. They collect just this material without any addition, and then they recycle them and put it again in the market. There are some positive opinions published in the website of EFSA, in which the closed loop the closed loop is applied, for example, for crates, for vegetables and fruits of plastic, and mainly made of PP. In this case, it's not PET, the recycled material. Okay, so the global primary. Okay. Global primary plastic production and primary waste production, you can see here according to the industrial sector, published also in 2017, and you can see the consumption and the really plastics and the waste generation. And as you can see that the most of the production is used for packaging. So that's why we we emphasize the packaging and the packaging applications because this represents the highest consumption and the highest production. Okay. Sorry, there are more people coming. Okay. You can see here also the plastics used in packaging and okay. And as you can see, PET is one of the highest, but low density polyethylene, for example, and high density polyethylene are also very, very abundant, as well as the PP. The other plastics are much lower. And also the applications, between the applications, okay, is the containers and the packaging are the most important ones. So the challenge you have for mechanical recycling rises from normally is the poor mechanical properties of the recycled plastics, because the thermal, mechanical, and lifetime degradation occurs also in this kind of in this kind of material, and also inclusion of immiscible plastics during the recycling process. I don't know if in the previous module you have studied some characteristics of the materials and on the plastics. For example, imagine that we want to recycle PET. PET, the melting point is 265 degrees Celsius degrees. And for example, there are some contaminants from polyolefins, PVC or polyethylene, low density polyethylene. These polyolefins have, for example, polyethylene, low density polyethylene has a melting point around 120, 130. So then you can imagine that when increasing the temperature for melting the PET at 265 degrees, the polyethylene is burned. So plastic burn means that there will be some black points, you know, and a black contamination. So this is the immiscible plastics during the recycling process. That's why in the recycling plants, always they have to apply always a strict separation and of different plastics because they can't process as the contaminated material, for example, in the case of PET, contaminated with all the plastics. So they have to put and to increase and to establish a limit, strict limit of percentage of other kind of plastics, mainly those that have much lower melting point. This is a question also to take into account what happens or what can happen with some bio or compostable materials. For example, PLA. PLA in appearance, as the aspect is very similar to PET. Melting point is quite high, but as consumers, we don't distinguish the PET from PLA. Fortunately, at the moment, there is not a high volume of PLA in the market. But when PLA increases in the market, we will have a problem in the recycling plants. Why? Because the distinction is very difficult by hand, of course, and also they will damage and they will affect the recycling system, the mechanical recycling of PET. So this is something to take into account, to consider in the near future. There has been significant progress also in sorting technologies. You will see in the video from Coca-Cola, there is a detector that you will have probably to pass or to stop the video just to appreciate that. But I'm going to explain you. It's a detector that is able to identify 100,000 spectrum per probably, I don't know, per minute or per hour. I will check the data, but a lot. And it's working with flakes. This detector was developed and optimized with the financial help from Coca-Cola by one specific company called Unisensor. Okay, and then this detector is very, very powerful for detecting based on the spectrum of each material. So examine every single flake and then sort the material, the flakes which are contaminated, not clean enough, or from other materials. So you can see in the video from Coca-Cola, okay? The chemical contamination on recycled plastics represents another obstacle for applications and products, because these chemicals might endanger the consumer health, especially when this recycled material is dedicated for food contact materials. Then the new packaging applications require a very, very good and very clean material for being recycled. I have to say that, for example, the technology applied to make the bottles, for example, the PET bottles, can't be applied when the material is not quite pure. So the material should be should have intrinsic viscosity right enough for injection molding, okay, injection blowing mold. So this is another guarantee. But this doesn't mean that the PET recycled PET bottles will be always completely clean, and requirements of controlling and strict cleaning is necessary. Okay, the potential contaminants in recycled plastics, you can see here the comparison between the PET and the PP, for example, in terms of concentration of the contaminants based on the molecular weight. You know that these are the ppm and also the molecular weight. And as you can see, the PP are much more prone to concentration. Okay. PET recycling. The reasons that make PET bottles is the ideal input material for bottle-to-bottle recycling. For example, the first one is the ease of separation from other waste. Okay, but also the easy removal of non-PET caps and labels, as well as the colored PET. PET doesn't take many compounds because the absorption capacity of PET as material is quite low. So this is just the opposite with polyolefins. So this means that we could remove easily the surface, the contamination from the surface. PET is very, very clean material itself from the first production. Virgin PET, then few additives are needed. So we don't need to control additive status in the PET recyclates because PET barely have additives, only the catalyst and more, nothing else probably. So minimal contaminations from printing inks because at the moment printing inks are not applied directly on PET. The PET bottles contain always labeled. I have to say that 2-3 years ago, I saw one new development in which they completely printed the PET bottle just to eliminate the label. Fortunately, I haven't seen this kind of bottles in the market because this would be terrible for the recycling. It could be terrible because the printing inks is a compendium of chemical formula, not only the dyes and the colorants and so on, but a compendium of many chemicals. Many of them are toxic for human health, and then it could be a complete disaster to print directly the PET bottles. Okay, PET is quite inert in nature, so this facilitates the recycling as well. The food grade of quality of all PET or material for food and non-food applications. I think PET for non-food quality, it doesn't produce. The compensation of properties lost for the rebuilding polymer chains with the help of solid state polycondensation. In fact, the solid state polycondensation, if you have seen it in the previous module of a technology, increases a little bit, not only eliminates the contaminants, but also increases a little bit the length of the chain, of the polymeric chain. So the solid state polycondensation means that the material will be stuck at high temperature for several hours, and then not at melting state, below melting state, okay? But this is a solid state polycondensation and favors the cleaning of the material. In some cases, they apply vacuum simultaneously. In some other technologies, the vacuum is not applied. And also the low absorption, I mentioned capacity of PET. Then this means that a few contaminants will be trapped in the polymer, and also the low diffusion coefficients through the PET matrix. So this again favors the transfer of compounds or contaminants from the PET wall to the food or food contact. So we will see some videos now. Okay, you have the link here. Okay, we will continue. Then working with and talking about the recycling, the traditional washing processes capable of removing contaminants from the surface, as we have mentioned, but not all the substances that have been absorbed. Then that's why the recycling process, the traditional one, is not sufficient for direct food applications. And then some of them are are called super clean technologies. They started many years ago to okay, to implement and to put in the market the super clean technologies. Nowadays, most of them are not called this way, but really they have improved quite a lot for cleansing the PET after conventional washing. Usually the different steps of recycling involve the high temperature processes, application of vacuum, application of inner gas, and also surface treatment as SSP I mentioned before. Okay, the closed loop, I already explained what does it mean. I don't know what happens. Closed loop of PET beverage bottles. I have seen that in the chat that in Finland you have exclusively collecting the PET bottles, and then 95% of PET bottles are recycled. But anyway, they need to be cleaned and processed again for in case you need and you want to apply them for food contact materials. Other plastics are not nowadays not yet recycled in a closed loop with some exceptions. For example, there is a positive opinion in UK for milk bottles made of high density polyethylene. This is the only application okay, with positive opinion for this kind of application and in a closed loop application. And also there's another one in closed loop for PP, as I mentioned before, or for crates, for vegetables and fruit in Italy. Most of them are downcycling for non-food contact applications because they can be contaminated in an unpredictable way, and they are still difficult to be sufficiently decontamination or decontaminated. And the main difference also not only the melting point and the characteristics of the materials, as you have studied already, but PET is a classic polymer, and or polyolefins rubbery. So for a given chemical, the diffusion coefficient is orders of magnitude lower in PET than in polyolefins. There are several publications dealing with that. So the high diffusion means that they can absorb much more contaminants from previous uses, and also they can transfer very easily the contaminants through the matrix, the polymeric matrix. Here you can see okay, one scheme of happens when we have a plastic material in contact with food, because the plastic film, or this is for films or for plastic, for any kind of plastics, but mainly for flexible materials. The flexible materials contain stabilizers, contain plasticizers, contain antioxidants, contain monomers, and then so on, and everything can be transferred to the food in contact with all of them. So from this contamination or this transfer, we can distinguish between the two main groups of the contaminants of the materials, which are called migrants, because there's a migration process between the plastic layer to the food in contact, which are the intentionally added substances, is the main group. And second one is the non-intentionally added substances, in which we can distinguish between the contaminants themselves, but also degradation products from the different manufacturing process, also from impurities from the raw materials and the monomers, original monomers, manufacturing, and so on, and also the reaction products. And you have to take into account also that when you have the final format of the plastic material in contact with food, there is not only the plastic itself, but the plastic with the adhesives in case of multi-layers, but also the printing inks, varnishes, and the different layers used to build the multi-layers to provide them the high barrier material, for example. And all these kind of chemicals, all these contaminants can be transferred through the different structure, the different matrix, and then arrive to the food and contaminate and affect the human health. That's why there will be, and there are strict legislation at European level that controls and obliges the companies, any company, to control the cleaning and the purity and the absence of migration over the limits established by the legislation. In the last, in the next module, we will talk about the legislation, and we will see some details about very important details about that. So there are also possible food residues from previous uses, such as limonene, for example, or persimmon, or whatever. Okay. This is just an example of the migration of the different recycled materials. These are coming from the one study we have done with the recycled HDPE, which is the high density polyethylene, intended to be recycled for food contact. This is the previous step because it's not yet at in market. Fortunately, of course, because we need, and then this is a demonstration that we need to increase and to develop additional technology, because this material has been processed just by washing and pelletizing, which is the extrusion under different conditions. And you can see many different samples, and using like migration simulation, and there are this is a fragment of the very long table of compounds we have found, and you can see that this is expressed in ppb, but the limits of for some of the compounds are much lower than the values we found. So we need to increase the technology, and we are working and processing in this, working in this field. We have uploaded also the thesis, doctoral thesis, dealing with the recycling polyolefins. There are a lot of information there. Not only about the state of the art on recycling, but also with the experimental work done with applying not only for recycling HD potential recycling HDPE for milk bottles and coming theoretically from milk bottles, but also for mixtures of polyolefins, mainly low density polyethylene and polypropylene mixed coming from the flexible materials and multi-layers and so on. So I think it's a very illustrative, it's quite technical thesis, but you can you have as the supplementary material in that. So this is the end of the presentation. I will stop the sharing of the presentation. I would like you to open for questions and doubts, or whatever you want to comment. Okay, you have seen the videos. I'm afraid you have seen different steps. Even though these videos are very illustrative, I think it's the video from Coca-Cola you have in the Moodle is probably more illustrative, okay, because you pass through the different selections, okay, and the different selections for the material. There's the first cleaning and packing and sorting, and then again detection, and again cleaning, and again detection, and finally as the blow molding. Okay. Do you want to ask something to comment?
Yes, you mentioned about this problem of contamination and not so easy recycling when we are talking about those new alternative packaging materials.
Yeah.
Can you give us some example why they are so challenging?
Yes, it is a challenge because the PLA bottles, I don't know if you have in your countries the PLA bottles for food contact, but the PLA is nowadays is a biomaterial that it is produced at industrial level. Concerning the biomaterials, I think is the number one because there are several plants producing a high number of tons per year of PLA. PLA is not very easy to process, but it's slowly coming in the market, and nowadays it's coming into the market to substitute the single use, for example, and I have seen also some bottles. At the moment, most of the bottles are PET, and because the PET is recycled, and I haven't seen in the market the PLA, PLA bottles. But the problem is that as you can't distinguish, apparently, just by watching the PLA and PET, you can't distinguish between them. Then if you put in the recycling system the PLA, finally they will be mixed with the PET, and PET goes to be recycled unless spectroscopic techniques will be used for distinguishing and for sorting PET and PLA. They can be contaminated. It can be contaminated by PLA. You have to know that PLA is promoted as compostable material. It's a biomaterial really, but it is promoted as compostable material. But in fact, it is compostable only under industrial conditions. So if you throw out the PLA bottle or PLA tray into the water or into the ocean, it's not correct. Okay, and if you put in land, it's not degraded because it needs specific temperature and humidity conditions. Then these conditions are applied at industrial level. Okay, this is one of the problems that we have now. I don't know if there is some member state in which there is specific collection for the material. At the moment, in Spain at least, we don't have enough volume to organize the compostable materials collection. Okay, then they are all together with other plastics, and they are not very easy to distinguish. That's why I mentioned that this is challenging, and this can be a risk in the near future with the compostable material.
Thank you.
More questions?
Sorry, Asier Carvalho, you have your microphone on, and maybe from there voices come. It's hard to listen.
There is also Elena, probably, that should have go on mute.
Okay. Any other question? Something else you want to comment? I want you to emphasize the importance of the recycling, of knowing details and technologies, and okay, as much as possible about the recycling and about the recycling plastics. Why? Because according to the European Commission, you know, and we will see in detail in the next module, but okay, no, in the next part of this module, talking about the legislation. But you have to know that every recycling plant producing recycled material for being in contact with food needs to be audited. Okay, needs an audit. There are not, at the moment, there are not auditors in Europe. European Commission promoted and organized and financed different courses in some in European countries for training the auditors for this kind of okay, audits of recycling plants, you know, producing the not only PET, but any kind of plastic material. There is a big gap in this area. So this gap could be and should be filled in with new people, and the new people will train with enough information, enough knowledge about the recycling technologies, about the recycling plastics, and about all these contexts. All these contexts. So I encourage you to okay, to learn as much as possible in this area to be able and to act as auditors in your own countries, because for sure you have several recycling plants as we have in Spain as well. And at the moment we don't have any audits in this context. So, but they are obligatory. Okay, so you know that the Commission is now revising the okay, the legislation on food contact materials as well as in recycling materials, because the recycling materials, the legislation nowadays only affects the mechanical recycling. You have now in the module more details about the chemical recycling. Chemical recycling is now starting, even though the first patents were launched about 20 years ago, more or less, or even more. Okay, but as the mechanical recycling was rapidly developed and with efficiency for PET, chemical recycling was stopped. But nowadays, as there is a big market of recycling and encouraged by the European Commission that we can't disregard the plastic, we have to avoid the single use, and a lot of material is not able for being recycled again because it's very degraded. Then the chemical recycling starts again. So there are now companies in Europe trying to produce a very good material from chemical recycling. You have seen in the module that the chemical recycling involves the obtention of the original monomers and to be polymerized again and produce the new material as it were virgin material. So we have already also studied some some starting materials coming from the hydrolysis, coming from the chemical recycling, and at the moment they're very good. They're very good. So I hope that in the near future we will have a very good material coming from the chemical recycling, and the new legislation will involve as well the chemical recycling in the legislation for recycling materials, as well as other details that nowadays are confusing in this kind of in this frame. So okay, this is what I wanted to comment. Anyway, next on 4th February, we will have another synchronous session in which we will be talking about not only the LCA, the life cycle analysis. You will see some practical example, and also we will comment something else about legislation on recycling material for being in contact with food, which is the highest demanding and the highest restriction for cleaning materials and so on, and recycling materials and so on. So do you have something else to comment? Do you want questions?
Thank you very much for a nice presentation. Yeah.
Very interesting. Thank you.
Okay, thank you. And okay, time is over. Then if you don't want to to comment or to ask any other question, anyway, you have also not only the Moodle through the Campus Iberus, you can ask questions, you can add comments and so on. Please watch the videos, do the activities, any question you may have, ask question both to Elena and to myself through the Campus Iberus, and that's it. Okay, Elena, do you want to add something?
No, I think it's all very clear.
Okay, then a pleasure to meet you, even though with this system. I'm very sorry for the videos, and okay, we will. I will check again the computer, but just and the system to share the videos apart from the presentation. And thank you for your attention.
Thank you. Bye bye.
Thank you.
Bye-bye.
Bye
Thank
bye.
you.
Have a nice evening all.
Thank you.
Bye.
Thank you. Have a
Nice
nice
to meet you.
evening. Bye bye.
Bye-bye.
Bye. Bye.